Hello, everyone. Thank you for virtually attending my talk today. Big thanks to the organizers who have had to switch gears and move this conference to a virtual format. My name is Adele. I'm a PhD student at Cardiff University studying Iron Age mortuary practice in Southwest Britain. And today I'm going to introduce you to a project that Ollie Davis, my supervisor, Rich Madgwick, and I have been working on titled Life and Death in Iron Age Wales. This project has been generously funded by the Cambrians, and I am super grateful and so excited to be a part of this. For this presentation, I'll start with a bit about the background of the project, describe the methods that we're using while giving little updates along the way, and wrap up with some conclusions. We were obviously stalled because of the pandemic, but we have managed to get some really interesting preliminary results that I am able to share with you. I just want to give a quick content warning that there will be some images of and from human remains in this presentation. The project started really when Ollie Davis compiled all the burial data from Wales and realized that there's actually a lot more evidence than what had been talked about in previous Iron Age studies. This means that there's a big gap we can fill because compared to, say, Wessex or Yorkshire over in England, we really don't know much about the people of later prehistoric Wales. We know almost nothing in terms of mortuary practices, mortality profiles, health, diets, and origins. As more and more evidence is being found in Wales, it's becoming more obvious that it wasn't just some frontier on the margins of society, but rather it had some extremely important and thriving communities with their own unique art, culture, and funerary rites. An example of this is, of course, the late Iron Age chariot burial recently found in Pembrokeshire, which Adam will tell you all about in a minute. This project is sort of the first probe into the lives and the deaths of the Iron Age population in Wales. The aim of the project is to address how we understand mortuary practices, but also to reveal new insights into the demographics of later prehistoric populations. To do this, we're using case study sites that have the most and best preserved human bone. That's RAF St. Athan in South Wales, with a little bonus edition of a single human bone fragment from Ollie's excavation at Cairo. And probably the most exciting case study is Dinorben in North Wales. We intentionally sampled a hill fort and non-hill fort site from contexts within and outside of the settlement areas. I'll now give a little bit of detail into these sites for some context into what we're working with here. First, we have St. Athan, case study number 1. It's a small defended enclosure in the Vale of Glamorgan, located within the RAF military grounds. So this is the non-hill fort site. It's one of the most extensively excavated enclosures in Southeast Wales, and during the excavations in 2002 and 2003, the remains of 5 individuals were were found and radiocarbon dated to the Iron Age. That's 2 Middle Iron Age inhumations from shallow pits outside the settlement, and some disarticulated late Iron Age individuals from within the settlement. The remains are very fragmentary, so what we can learn from them is limited in terms of metrics, taphonomy, pathologies, etc. But it was noted by the osteo report that the individuals seem to have lived quite hard lives. Their skeletons, or what was left of their skeletons, suggested some intense and prolonged manual labor. So it's thought that life was a bit hard for the people buried at St. Athan. Then we have Cairo Hill Fort in Cardiff. I'm calling this one case study 1.5 because it's only one lonely bone fragment radiocarbon dated to the Middle Iron Age, and it was found in an enclosure ditch, but I figured it was worth adding to the mix. Why not? Cairo is located essentially in a housing estate in Ely, and field school excavations and community excavations led by Cardiff University go on most summers, so hopefully we will get some more human bones at some point. It is a pretty big hill fort with a long history of occupation going back at least the Neolithic and continues up to the late Iron Age and beyond. Case study site 2 is Dinorben. It is a large, albeit now destroyed, hill fort in Conwy, North Wales. Iron Age occupation here spans from the 5th to the 1st century BC and continues to be used well past the Roman period. The excavations first occurred here in 1912 through 1922, and subsequent excavations responding to quarrying happened in the 50s, 60s, and 70s. Quarrying has since completely consumed the hill fort, and there's almost nothing left of it, which is horribly tragic after being such an icon on the landscape of Wales for thousands of years. But a tiny silver lining is that it's now one of the best known and published hill forts in the country. There were 15 records of human remains identified at the site. I think all of them were disarticulated. There is a predominance of skulls or skull fragments here, which has inspired theories of headhunting cults and war trophies, which is always fun. The context recording isn't the most thorough, but we know that the human remains were found in all sorts of places here. They were in enclosure ditches and pits, as you would expect, but also on hut floor surfaces, which is a bit unusual. It's also worth mentioning the famous ox-head escutcheon found on the road leading into the main hill fort entrance. I just think it is super cute. So to learn more about these sites and the people that were buried there, we're coming in all guns blazing, really. We're pulling out all the stops here. First, we need to do some radiocarbon dating, which will help improve the chronology. Second, we've got multi-isotope analysis to tell us about the lives of the people represented through their diet and origins. And third, we have histological analysis, which will tell us about the early postmortem treatments or funerary processes afforded to the bones. So, radiocarbon dating. There are only 20 radiocarbon dates for the later prehistoric period in Wales, and since the context at Dinorben is so sketchy, we are radiocarbon dating 5 human bone samples from different contexts around the site. This will help us further develop the chronology of Iron Age burial in Wales and Wales in general, and it will tell us more about the individuals that are buried at Dinorben. I don't have any results to report on yet, but we are expecting them literally any day now, so watch this space. That brings us to isotopes. Everyone loves isotopes. They give us so much information. So for this study, we've sampled 5 individuals from St. Athan, from 7 from Dinorben, and 1 from Cairo for carbon and nitrogen isotope analysis, which are the diet isotopes. I'm still waiting on the results from a few samples that I had to prep later, but I do have some results that I can share. So here are the results from 10 of the samples. You can see that there is an interesting pattern going on here. The Cairo guy falls really nicely in with our friends from St. Athan. And what I think is most interesting is that Dinorben, the samples from Dinorben have higher nitrogen values overall. This may indicate that the people at Dinorben have a more meat-rich diet than the people in South Wales and St. Athan and Cairo. This might be because of a difference in subsistence strategies, or it might be related to status. So, maybe the people buried at Dinorben had more access to meat than those at St. Athan. Or it might have to do with the landscape. The soils might be more nitrogen rich. They might be doing some more manuring of the crop fields, which can give a higher nitrogen content overall. These results are fresh out of the oven. So when we get the results back from the remaining 3 that we're missing, we'll investigate the geology at the 2 sites to see if the difference in the nitrogen is likely to be directly related to meat consumption or not. There's also this little outlier from Dinorben here, which is kind of strange, and it may indicate that the individual was not local to the area, which is pretty interesting. So I'm really excited to get the radiocarbon results back to see if this individual is contemporary with the others at Dinorben, if it's even Iron Age. In addition to the diet isotopes, we're going to do some strontium analysis and oxygen isotope analysis on the teeth from Dinorben and St. Athan, which will tell us whether the individuals sampled were local to where they were buried or if they came from elsewhere. It is a shame that the outlier sample here wasn't a mandible with a tooth or something, so we could get, so we could test whether or not they were local with the strontium or the oxygen, but it'll be exciting to see the results of the ones that we do have anyway. Moving on to the histological analysis. This is my personal favorite thing to talk about. I am obsessed with histology. I use histological analysis for my PhD research, so I'm so sorry if I go off rambling. I'll try to keep it short. As I mentioned, the bones that we're working with are really badly preserved and super fragmented. So to answer some questions about burial and funerary treatment at the site, we've used histological analysis, which involves cutting a very thin transverse section of bone so that we can see the actual bone microstructure under the microscope. And what we're looking for is bacterial or fungal attack. The idea here is that the longer a body is left whole and intact to decompose, the worse the microstructure preservation will be. This is because the bacteria that live in our bodies, particularly in our gut, go absolutely buck wild and start to decompose us from the inside out. It enters our bone structure through tiny little pores that are used to transport nutrients during life. So the bacteria eats the collagen and we're left with this really dark, murky image where you can't really see any bone microstructure. It's like this one here. On the other hand, if a bone is quickly removed from a body shortly after death, the microstructure will be really well preserved, like this one here. Both of these images are from my PhD research. They're from the same Iron Age site in Gloucestershire. The bad one is from an inhumation, and the good one is from a long bone that was found in Pitfill. You can see that the periosteum on the bad one is completely eroded away, and the sample is just covered in this thick, opaque, dark stuff. That's bacterial attack. Compared to the other one, you can see that there's the thin band of periosteum, which is still intact, and you can see all of the features of the microstructure. The little osteons are called, they look good as new. So we score the preservation of each sample on a scale from 0 to 5, with 0 being complete destruction of the microstructure with no recognizable features left, and 5 being perfect, like from a fresh cadaver. So generally speaking, you'd expect an inhumation to look like the one on the left, which has a score of 0, and an excarnation or dismemberment to look like the one on the right, which has a score of 4 or 5. So with this in mind, let's take a look inside the bones of our friends from Wales. The samples from St. Athan score low overall. They've clearly undergone a lot of microbial attack. Some of them are completely destroyed, especially RAF01 and RAF04. But some of the others have patches or clusters of better preserved microstructure. There's more collagen that preserves in some of these little patches here. It's similar, a little bit similar to what's called arrested attack, where the diagenetic bacteria gets interrupted suddenly, which can be from a change of environment or rapid skeletonization. It's really slight in these samples though, and overall the destruction is advanced as you would expect in typical inhumations. The one sample from Cairo is pretty strange. As you can see, it's very poorly preserved. There's no visible microstructure remaining except for a single little osteon there at the top. But what's weird is this kind of layering or different colors of microbial attack. You can see the top right corner here has dark brown stuff focused around the little pores. And then there's sort of a margin of medium brown stuff. And then in the bottom left corner, there's an even darker type of attack. Under polarized light, this is even more obvious. And I'm not really sure what this means exactly, so I have to take it away and do some more research on this, but I'm thinking it could be something like changes in deposition environment. And finally, there's Dinorben. Despite the bones being disarticulated and deposited throughout the site, the microstructure preservation at Dinorben is really, really bad. Each sample score is a 0 on the scale. They're thoroughly destroyed right on through the whole transverse section. This includes the mandible and the crania fragments. They're both completely covered in microbial attack, which is interesting because, it would suggest that these were bones that were once part of a corpse that had been whole and buried and left to decompose. And then later, at some point after skeletonization, it was disturbed and disarticulated. So what does it all mean? Well, the results from the histological analysis suggest that the bones from all of these sites were probably from inhumations. The circumstances that led to them, ending up in and around the settlements, in the pits and the ditches, that part's unclear. It could be from accidental disturbance during later earthworks, kind of like they suggested was the case in the report at RAF St. Athan. But this is becoming such a regular occurrence for Iron Age settlements. Human remains are coming up in ditches, pits, post holes all over Southwest Britain. So to me, it's starting to seem like more of a discrete funerary rite in itself. So it could be that the disarticulated elements are being deliberately selected from inhumations specifically for redeposition. And this aligns with Neil Sharple's theory that the, quote, normal burial rite was inhumations in shallow pits on the edge of contemporary settlements. The idea being that once they're buried, they become generic ancestors, and then their bones could be removed by the living in rituals conducted within the settlements. In any case, based on these results, it's unlikely that they were the product of excarnations or war trophies or headhunting. And this is pretty significant because excarnation has been the go-to theory to kind of explain away the lack of Iron Age burial evidence and to explain the seemingly, random scatter of human remains across the sites. So what's next? Where do we go from here? Well, once we get the radiocarbon dates for Dinorben, we'll be able to put these into context with the other dated burial evidence. It'll be really interesting to compare these with St. Athan, since at St. Athan we have both shallow inhumations and disarticulations. The results from the strontium and oxygen will be really interesting because it'll tell us if the people deposited in and around the settlements are local to the area or if they come from elsewhere. This will be especially interesting, again, for Dinorben to further test the, quote, war trophy theory, because if we keep analyzing disarticulated bone from enclosure ditches and they're all coming up as being local, then we kind of have to change our thinking from displaying hunted heads to honorating the venerated dead. But only time will tell, and of course, more comprehensive analyses like this applied to more Iron Age evidence from Wales. And lastly, we have a couple more samples to beef up the diet, pardon the pun, which will add a bit more data to the map, and it'll let us see if the difference in nitrogen between Dinorben and St. Athan is still as stark as it appears. And once we have all of the results in, we'll be able to synthesize all this new information, and together it will form the first really comprehensive look into life and death in Iron Age Wales. Thank you very much to the Cambrians for all of your support and patience. Big thanks to the National Museum Wales for allowing me access to the bones, and of course to Cardiff University for giving me a home and all the labs and kit I need to do all of this. Thank you very much.